have a pen. See that pen.
In essence, gears change the speed and direction of the movement within a gear system. In this case, we're taking the turning motion and power from this part of our machine and we're transferring it to the rear tire, another part of our machine. Now this is a good example with a bicycle in your classroom to introduce gears. It's kind of exciting to see a bicycle upside down in one's classroom here. And have your students walk around the bike and take a look at the gear system and ask them what happens when you turn the pedals. What other parts of the bicycle are in motion? They can draw this and note this, record this within their journal. You want to ask them, where are the gears on the bike and what do they look like? You can brainstorm what it is that gears do and how they work. Have your students walk around and note how many gears there are and ask them why the gears are different sizes. What's that going to do within the gear system, and in this case when riding a bike. So now the next activity with them is to take a piece of chalk and put a mark on your rear tire. In this case I have it right here, and set it at a reference point. I'm going to use the frame. I'm going to do the same with our pedals. Now I'm going to set the bike on its lowest gear ratio and have a volunteer come and turn the pedals, and the rest of the class can count how many times the rear tire goes around while watching that chalk mark. You'll notice at the lowest level on this bike, it's a 1-to-1 ratio. So 1 turn for the pedals equals 1 turn of the rear tire. Why is that? What gears are being turned here? What are the size of those gears? Now, you also want to try this for the highest gear on the bike, and then you'll see what gears the highest ratio sits on. You want to make note of that and count how many times the rear tire moves around. It'll probably be about 3 or 4 times. So what gear would you want to be in if you were climbing a really steep hill with your bicycle? Or what gear would you want to be in if you wanted to go really quickly based on the information that we know? What you're likely to notice with your students is that in the lowest gear selection, the bike is going to pick the small gear up the front and the large gear at the back. And they're roughly the same size. We see that when we turn the front pedal, the rear tire turns at the same rate. And that's because they're the same size. We have a 1-to-1 relationship. Now in the highest gear, it's going to select the largest gear at the front and the smallest gear at the back. And we see the difference in size of those gears lends to the tire in the back turning quite a few more times than the pedals here at the front. So have your students count how many teeth are in the small gear at the back and the large gear at the front, and see if there's a similar relationship between the amount of spins in the rear tire versus the pedals. Now, we have little mechanical advantage here when we're in a high gear, but we have a higher rate of speed. Similarly, low speed in a lower gear, but a greater mechanical advantage. We've just taken a look at a bicycle and how gears help it in its functioning, and now it's time to really get hands-on with gears so that we understand how they really work. So ask your students what objects in their surroundings function with the help of gears other than a bicycle. They might come up with items that they're familiar with, such as a watch, can opener, maybe a guitar, a wrench. These are all great items that you want to keep track of as the unit progresses. Now, if you have access to a commercially created gear system, they're really easy to put together and to take apart, and they're not time-consuming to work with, which is really a plus in the classroom. Now, if you don't have access to that, you can find individual gears at a dollar store or at a similar outlet that you can pin to some cardboard and create some really creative systems in this format. Now, if that's also not an option, you can create some gears at a poster board and some pins and cardboard as well. I'd advise you to print out some templates, glue them directly on the poster board, cut them out, and raise the teeth up so that they mesh appropriately when you put them together. And once you have a system such as this here set up, have your students explore that in sort of an unstructured way, and then you can ask those key questions about the relationship in size, the amount of teeth. You might want to mark one tooth on each gear so that they can see how many times they go around and the relationship between them. The idea is essentially that gears transfer force from one place to another. These are questions that you want to focus in on those ideas, that they change the direction of a force, they also change the speed of a force, and they increase that turning force. So you want to introduce the idea of torque and clockwise versus counterclockwise motion, and similar ideas such as this. Now, if you have a commercially set up gear system, they often come up with different plans, so you can challenge your students as a culminating activity to put other things together and to construct, maybe with use of an axle, a watch system to turn an hour hand and a minute hand. They're quite fun and creative. So have fun with gears. Hopefully the activities and demonstrations contained within this video will help you to communicate that both pulley and gear systems transfer motion from one place to another, transform one kind of motion into another, change the direction and speed of an object's motion, as well as change the amount of force required to move an object. Now these devices are generally used to make our everyday lives easier, and when combined with the spirit of inquiry can be kind of fun to explore with your students as well.
Hello everyone, and welcome to our video lesson on integers and BEDMAS. To get started, we are going to talk a little bit about some of the numbers that you already know about from your previous math classes. And we'll start with the natural numbers. The natural numbers are the numbers starting with the number 1 and going up by ones as far as you can count. So I've listed a few examples like the number 1, 2, 3, and 4. These are all natural numbers. And this pattern that I've established continues. Those 3 dots mean and so on. You'll notice I've put these numbers in this pattern, a natural number pattern, in a set of brackets. These brackets are called set brackets. So the natural numbers are the numbers 1, 2, 3, 4, and so on. They have a special symbol, and that symbol is this fancy letter N. And that's the symbol we use in mathematics for the natural numbers. There are other types of numbers that you've learned about. You'll notice the number 0 is missing from my set of natural numbers. When we include 0, we say we're working with the whole numbers. The whole numbers is just the set of natural numbers including 0. And if we were to use a symbol to represent the natural numbers including 0, we would use the fancy letter N with a little 0 at the bottom. And then finally, you've worked with the integers in the past. Integers are positive and negative whole numbers. So the numbers -3 up to 3 and so on in both directions. Just to restate, these are positive and negative whole numbers. So the integers are positive and negative whole numbers. We can think of the integers as being represented on a number line with 0 in the middle, the negative integers to the left of 0, and the positive integers to the right of 0. And we could say that numbers like 4 and -4 are opposites of each other. So if we think of integers on the number line, if we're adding integers, adding means we're taking a number and moving to the right. So adding moves to the right. And if we're to subtract, subtraction is the opposite. Subtraction moves on the number line to the left. Let's try some examples. If I wanted to determine what -3 take away 1 equals, I could think of -3 on my number line, find it on my number line. And we said that subtraction means we're moving to the left. So -3 take away 1 means I'm moving to the left 1 spot. So -3 take away 1 equals -4. So if I try another question, like -2 plus 5, well, I find -2 on my number line. And then now that I'm adding, I'm moving to the right 5 spots. 1, 2, 3, 4, 5. -2 plus 5 is equal to +3. We'll try one more example. 3 take away 7. So I find 3 on my number line, and I'm subtracting 7, so I'm going down 7. And on the number line, when I move from 3 to the left 7, I end up at -4. So -3 take away 7 is -4. So that's adding and subtracting with integers, and now we can move into multiplying and dividing with integers. And to do that, we need to remember our sign combinations. So if we're taking a positive and we multiply by a positive, 2 positives together, our overall answer is positive. If we take a positive number and we multiply it by a negative number, or we divide it by a negative number, our overall answer will be negative. Vice versa, if I take a negative number and I multiply or divide by a positive number, my overall answer is still negative. And if I take 2 negative numbers and multiply them or divide them, my overall answer is positive. So as an example, if I have the number 5 multiplied by -1, I have a positive number, 5, times a negative number, 1. And when I multiply these two numbers together, my overall answer is negative. 5 times -1 is -5. Likewise, -8 multiplied by -2. Well, I have 2 negative numbers now being multiplied, so my rules tell me my overall answer would be positive. 8 times 2 is, -8 times -2 is +16. One more example, -12 divided by 3, +3. Again, I have a negative number divided by a positive number, so my overall answer will be negative. 12 divided by 3 is 4, so -12 divided by +3 is -4. So we've looked at addition, subtraction, multiplication and division on its own. Now let's start putting it all together, and when we put it all together, we need to remember BEDMAS. BEDMAS stands for brackets, exponents, divide, multiply, add, and subtract. BEDMAS tells you the order you should perform operations in, starting with brackets first and working your way down to subtraction. So a question like this, 8 divided by 2 plus -3 times -2, BEDMAS tells me to take care of the divisions first. 8 divided by 2 is 4, and I'm adding to that -3 times -2. BEDMAS next tells me to take care of the multiplications. -3 times -2 is +6. 2 negatives multiplied gives you a positive. And then finally we do the addition. 4 plus 6 is 10. Notice how, as I'm solving, I'm working down, not across. Also notice how my equal signs all line up. These are parts of good form in mathematics. So as we're solving problems, we always want to be working down, not across, and making sure in our questions our equal signs line up, and we only have one equal sign per line. Last question. 3 plus 6 divided by -2. Again, we start by solving the division. So we had 3 plus 6 divided by -2, when we have a positive divided by a negative, so that ends up being -3. As we're working through this question, I have 3 plus in brackets, -3. We have to imagine that there's a invisible number 1 in the front of that bracket, which means I'm really multiplying 1 times -3. Positive 1 times -3 is -3. And then my final answer, 3 take away 3, would be 0. Again, I'm working down, not across, and I have one equal sign per line.
Canada is a huge country, and each community has its own unique needs and interests. To serve Canadians most effectively, the government is split into 3 levels. The federal government is responsible for the entire country. Provincial and territorial governments are responsible for their province or territory, and local or municipal governments manage their city or town. So, what exactly does the federal government do? They handle all matters of national and international concern, like national defense, foreign affairs and trade, currency, fisheries and oceans, and citizenship and immigration. Provincial and territorial governments are responsible for more regional issues, like education, healthcare delivery, natural resources, and transportation and highways. Local and municipal governments represent the interests of cities, towns, and villages, and they're responsible for local matters such as waste removal, water and sewage, libraries, and parks and recreation. In Canada, we vote for people to represent us at each level. These representatives are then responsible for proposing, studying, debating, and voting on bills, which are potential laws. Still unsure of who's who? Here's a quick overview. Federal elected representatives are called Members of Parliament, or MPs for short. They gather to debate and pass laws in the House of Commons in Ottawa. Then, depending on where you live, the provincial or territorial elected representatives are known as members of the Legislative Assembly, members of provincial parliament, members of the National Assembly, or members of the House of Assembly. They meet at their respective legislatures in the capital of the province or territory. Finally, at the municipal level, our elected representatives are normally called councillors or aldermen, and they meet at their city or town hall. Each level of government also has a leader. The head of the federal government is the Prime Minister. The leader of the provincial or territorial government is the Premier, and the leader at the municipal level is usually a mayor or a reeve. Every day, many parts of your life are impacted by the different levels of government, and each government is led by politicians that we elect.